Assalamu alaikum. Today we will talk about reliability. It is one of the measures of the product quality. What do we mean by reliability? A reliable person means he is able to do whatever, any assigned task to be performed. So by this, we can define reliability as the ability of what? We measure the ability of a system, a completed product, or a part of product. So the ability of a product, a part, or a system to do what? To perform its intended function under a prescribed or predetermined set of conditions. To know the reliability or to measure the reliability, we have to define cases of failure. Being able to perform means being successful in performing its intended function. So what if the product does not perform successfully? This means it fails. So the meaning of failure is a situation in which a product or part or system does not perform as intended. So we have two cases for a product to perform. Either to perform as intended or planned to perform, or does not perform as intended. So either we have a success in performance or a failure in performing. What do we mean by NOC? Normal operating conditions. Is the set of conditions under which an item's reliability is specified, which means we cannot measure reliability of a product under an open condition, but we have to determine some range of conditions or predetermined set of conditions under which it can perform successfully. Reliability can be measured by probability. How can we assign or define or measure the probability of performance? Either when function is to be activated, for example, talking about a project, mean that when it is activated, being on, it performs successfully or not. So it is performing when it is activated. Otherwise, we can measure its reliability for some specific period of time. Talking about electric lamp, we measure its reliability not by activating the lamp and observing whatever it performs or not, but we measure its reliability by its success of performance for a given period of time or length of time. That we call it the lifetime or the productive lifetime of the electric lamp. We measure probability or reliability being 0.9, mean that probability of success in performing its intended function is 0.9, or probability that the system performs as intended 0.9. How we have determined such 0.9? We have conducted 100 trials. Out of the 100 trials, 90 times of them were success. This means that 10 times of the 100 trials were considered failure. Okay, by this we can say that probability of failure or probability of success 0.9 and probability of failure is 0.1. This means that probability of failure equals 1 minus probability of success. Since we have only 2 cases for the product to perform, either performing as intended or not performing as intended, either successful or being failed. So this means that probability of success plus probability of failure equals integer 1. What are the different cases of failure? Is it one case only? Taking, for example, the smoke or heat alarm, the little lamp fixed on the ceiling of some halls or cinema or classes or mosques, that it's activated when there is a fire. Either activated, it has a sensor that is activating either by pressure of smoke or by some level of temperature, the heat, to detect having a fire. The failure had 3 cases. The first one, case of not working at all. This is the case, the most common case that we know, that it does not perform or work at all. Means having a fire but not working at all. It doesn't give the alarm that it should give to alarmed people. The other case, partial performance, which means half and a half. It means giving a very low or fainted alarm that does not preclude the people of the fire. So working once and not working other times, or giving low fainted alarm or signals, means partial performance. It's considered one of the failure cases. The third one, case of working where it should not work, which means giving an alarm without having a smoke or having a fire. So we have 3 cases of failure, either not working at all, or partial working or performance, or working where it should not work. What are the different types of systems? We have different types. System that consists of independent parts, or system that consists of dependent parts or events. Systems with independent or system with dependent or backup parts or events, or what we call it redundancy, as we will define it sometimes later. The independent events or parts, events whose occurrence or non-occurrence do not influence each other. They are independent. For example, having a car that is composed of 2 parts only for simplification, a battery and a motor. How can we calculate its reliability? Taking this numerical example, having or assuming to have a system or a product that's composed of 2 parts, A and B, battery and a motor, both are necessary for the system to operate. Their probabilities of success are 0.9 and 0.8 respectively. Represent or draw the system and calculate its reliability. Now, to draw this system, we have 2 parts. Part A, represented by a box or a square. We put the success probability inside the box, and part B as another box with its success probability 0.8. Now, since these 2 parts are the same, are necessary for the system to perform or operate, they are represented in a sequential way. They are put at the same level. Okay, now we have to calculate the complementary probabilities, the failure probabilities, and put them out of each box. Part A has success probability 0.9, so its failure probability 0.1. Part B has success 0.8, so its failure is 0.2. Now we have to define the kind of relationship that exists between both parts. Since both parts are important for the system to operate, which means the success of the whole system consists of or depends on the success of A and success of B. So we put and on the link between A and B. So by this, reliability or success of the whole system equals success of A and success of B. Now we have to transform this and into mathematical symbol. What kind of mathematical relationship? That says when one of these important or necessary parts, when one of them fails to perform, we will never get successful performance for the whole system, which means if its probability has decreased up to 0 level, this means that the reliability of the whole system will be 0. This kind of relationship is multiplication. So and is translated into times. Why? Because one of them, either B or A, each of them is necessary for the system to perform. So if its probability equals 0, this means we will get 0 performance or 0 reliability for the whole system. So reliability equals success of A times success of B. So this means that as a general rule, the kind of relationship between parts and is translated into time or multiplication. Now, having more than 2 parts, 3 parts or 5 parts or whatever, as in this example, we have 3 parts, but this time their probabilities of failure, whatever the givens are, success probabilities or failure probabilities, you can calculate complementary ones. A with its success 0.9, B success 0.8, and C 0.95. These are the givens. No, sorry. We have to assign their failure probability. So the givens are 0.1, 0.2, and 0.05. These are written firstly. Okay? Then, after that, we have to calculate the complementary probability, the success. So, out of the box of A, we write 0.1. For B, 0.2, for C, 0.05. Then we calculate the complementary probability. Since the failure is 0.10, the success will be 0.90. For B, 0.2 failure, so the success will be 0.8 and so on. What kind of relationship? And now, reliability of the whole system requires success of A and success of B and success of C, translated into times. So success equals 0.9 times 0.8 times 0.9. As a general rule, how can we conclude the relationship? Which means, what if the number of parts or components of a specific system is increasing? What happens for the reliability of the whole system? Let us have this example. Having a system that's composed of one part, its reliability or probability of success 0.9. This means that the R of the whole system equals 0.9. Now, increasing the number of parts or components. The system is composed of two parts. Okay, we have a missed S here in the parts. Each of them has a probability of success 0.9. So reliability equals 0.9 success of A times success of B. 0.9 times 0.9 means or equals 0.8 reliability. Increasing an extra third part or component. A system was composed of three parts. Each of them has a probability of success 0.9. So reliability equals 0.9 to the power 3 or 0.9 times 0.9 times 0.9 equals 0.7 something. Now we conclude that as we increase the number of parts or components in the system, what happens for the reliability? Assuming that all parts have the same probability of success 0.9. When we had one part only, it's 0.9, reliability 0.9. When we had two parts for the system, reliability equals 0.8. When we increased by a third part, the probability is 0.7. This means that 0.9, 0.8, 0.7. This means that as we increase, as the number of parts or component increases, the reliability decreases, which means the more complicated the product or the system, the lower its reliability will be. What does it mean? Having a very advanced or complicated product, having an aeroplane, a rocket, whatever complicated product, this means that its reliability will be low because of having large number of components or parts. Yes, it's a big problem. How can we deal with this situation? We have to use redundancy. What do we mean by redundancy? Redundancy is the use of backup or standby components to increase its reliability. For example, having the case of emergency light, كشاف اللي بينور في البيت في حالة قطع الكهرباء. A system is composed of one port that works for or with probability of success 0.9, having another backup port or standby port that has probability of success 0.8. Draw or represent the system and calculate its reliability. Now, the system can operate not with both parts, either with the first part, the original, or with the second part, the backup or standby. So we have the original part as a box with its success probability inside the box and failure probability outside the box. We have part A prime or the first backup part with its probability. They are represented vertically because we will never have both of them operating at the same time. The task is done by either A or B. What kind of relationship between these two parts, the original and the backup or standby? Either A or A prime, either the original or the backup. So the success or the reliability of the whole system requires success of A or A prime. A is working with its success probability. It has no conditions to perform. But A prime, how can A prime perform successfully? It will never perform unless there is a failure for the original one. So, or is translated into, since we adding a new backup part to increase or improve reliability, or is translated into plus. So we have reliability equals success of A plus some long story for A prime. What is the story of O prime? Coming from the early beginning. What happened? Unless A prime or the backup will perform, we must have a failure for the original part. Though, so this means that the two brackets of A prime consists of two events. Firstly, we must have a failure for original A, and at the same time success for A prime. Okay, so we have success of A, or for A prime failure of the original A, and at the same time success of A prime or success of the backup. This means that A will be times and or will be translated into plus. Success of A equals 0.9, or plus, open two brackets, for A prime. A prime or the backup part consists of failure of the original 0.10 times success of the backup 0.8. Okay, to another part with two backups. Whatever the givens are, all are success probabilities, all are failure probabilities, some of them failure and some others are success, the same. Put the given where it must be located and calculate the complementary probabilities. In the given example, we have three parts, one original and first backup and second backup, A prime and A double prime. Their success probabilities are assigned, and so the relationship between A or the original and first backup and second backup, the system will perform by either of them, either the original or the first backup or the second backup. So the relationship are translated into or. So reliability of the whole system equals either original or backup 1 or backup 2. How to calculate each of them? The or relationships are translated into pluses, addition. Original, the original part, its success probability is just 0.9. The first backup, its performance reliability equals failure of the original times success of first backup, plus third part or the second backup, its reliability equals the story from the early beginning, failure of original times failure of the first backup, and then success of the second backup or A double prime. Okay, so for each backup, as a general rule, for each backup to calculate its reliability, we have to start from the early beginning of the original. Failure of the original times failure of the second times failure of the third, and so on until the success of the specific part or backup. Okay, relationships are translated into pluses or ors. The original its success plus we have 3 boxes. For each 3 of the 3 parts. One of the for the original, one for the first backup, and another box for the third part. And define success for each of them. The original will perform with success equals 0.9 plus the first backup will perform with failure of the original 0.10 times its success 0.8 plus the third part will perform if the previous two have failed. Failure of the original 0.10 times failure of the first backup 0.2 times success of this part 0.7. Okay? The calculation. Now having different or complicated systems with different parts or components, original ones and backup ones, assign the relationship between all the links and translate these relationships. We have A and B and C, so we have 3 boxes. What about the givens? Assuming that we have a system composed of 3 parts, A, B, and C. Their assigned success probabilities are 0.98, 0.80, 0.95. Assuming that the second part, B, has 1 backup with success equals 0.9 and part C has 1 backup with success probability 0.92. Sometimes the givens may be in terms of failure probabilities, not success. It doesn't matter for us. Now we have 3 boxes, 1 for A and 1 for B and 1 for C. Reliability equals A times B times C. A has probability of success 0.98 since it consists of only 1 part, times for B we have 2 brackets, 1 for each box, 1 for the original and 1 for the first backup. The original will perform with success equals 0.8 plus the backup will perform if we have a failure for the original 0.2 times its success 0.9 times for C success of the original 0.95 or plus to perform the backup we have to have a failure of the original 0.05 times its success. Now another piece of information, what if all these backup parts are automatic parts, which mean they perform automatically in the case of the failure of the previous ones. Now, given that the last part or the backup part of C or C prime does not perform automatically, but performs through a switch, which means you have to hit or push a button. زي الكشاف اللي في البيت كده، في كشافات أول ما الكهرباء بتقطع هي بتشتغل أوتوماتيك، وفي كشافات تانية لازم تدوس زرار عشان هي تشتغل. الزرار ده هيفرق إيه؟ The same as an event in the sequence of their occurrence. The backup cannot perform unless the switch is performing successfully. The same previous problem, 3 boxes for A times B times C, A with success 0.98 times B 0.80 plus failure 0.2 times success 0.9 plus all that change will be located in part C. Either the original performs with success 0.95 plus what may happen, failure of the original times success of the switch times success of the backup. This means that we will multiply failure of the original 0.05 times success of the switch 0.94 times success of the backup 0.92. This means that in case of having a switch that must be located before the last backup, having a port with 5 backups, this means that it's composed of 6 parts. The switch will be located only before the last one, okay, the 6th one. This means that before the last one performs, before its success probability, we have to multiply by the success probability of the switch. Even if the information given in the problem is failure probability of the switch, we need to use the success probability of the switch. Now we have some factors to be considered to improve reliability, since reliability is used as a criteria or a standard for measuring quality of product through component design, improving the design of our components, or through assembly techniques, or extra testing, or using backups, or using preventive maintenance procedures, not waiting until we face some failure, okay, of parts or machines. We have to have good maintenance or preventive maintenance program, or through educating the user, telling him how to use the product successfully, or through the